Hello friends, good evening to all of you. I extend a very warm welcome to all of you to today's lecture on soil color, part of the BAU lecture series started at the behest of our Honorable Vice Chancellor Dr. R.K. Sohane. I am very grateful to him for providing me this opportunity to share my insights with you regarding this topic, soil color. You see, soil color, this probably is one readily observable soil property from which various other soil properties can be inferred. And you see, it's not a perfect yardstick, but still it gives you certain insights into various properties of the soil. Just by knowing the soil color, you can have a lot of information about the soils. So the objective of my presentation here is to share my insights regarding this concept with all of you. Okay, so as regards soil color, first of all, I would like to just appraise you what we are interested to learn or discuss about soil color in today's lecture. Okay, so I'll be concentrating largely on these points. First of all, what is soil color? I mean to say, how do you put in appropriate words the concept of soil color? How is this concept significant? What is the significance of soil color? What does knowledge of soil color mean to you or to others? Then what are the underlying reasons for specific soil colors? If a soil is black, if a soil is gray, if a soil is red, why is it so? What are the conditions? What are the varying conditions which have led to different colors of the soil? And then which specific component of the soil, be it organic matter, the mineral matter, water, whatever, and what are their quantitative amounts? How do they contribute to various colors? And then next would be graduating to how to determine soil color. You see, it's easy to say, assign a particular name, but those names have to be uniformly understood. If I say pale green, anybody else does not understand exactly what type of green. Light yellow could mean different for different people. So there has to be a uniform nomenclature, a scientific notation for representing soil color. So we'll delve into this also. And then how to represent the cases of non-uniform coloration. If there's a single color, it's okay. If you can see me here, okay, my shirt, largely you can say it's white, but there are certain designs, it's non-uniformity. So you need to characterize that non-uniformity or heterogeneity also in representing the color. Are we able to do that, or do we intend to do that? If yes, how? And after this, I will be putting up some questions as food for thought or as some homework assignment for the students, some questions to test your basic understanding, whatever you have understood from this lecture. Okay, so let's proceed. Now, first of all, what do we understand by soil color? Simply, what do you understand by color, first of all? Okay, a color is just a visual perception described through color categories or names. You have a certain perception in your mind that green is this and blue is this. So that is for a soil, if you have such a perception, to identify the visual signature of a soil is knowing its color, very simply speaking. If you can see a soil or see a set or some different soils and describe them with some with what you see, that will obviously be there will obviously be a mention of color, because soil color is actually a manifestation of the dominant wavelength of reflected radiation in the visible spectrum. You see, whatever color we see or we assign to a particular object, specifically here to soils, they are a result of the dominant wavelength which is of radiation that is being reflected through that soil. So for example, a red colored soil will be reflecting largely radiation in the red band, which our eyes can perceive as red color. And we have prior understanding that this is red color. And so we name it so. But such perceptions will have little direct influence on soil functioning. We won't be able to use this type of knowledge, simply identifying the colors. We won't be able to use it to know anything about soil functioning or soil genesis or whatsoever. Anything about this, anything further cannot be drawn about the soil only by knowing this color. But inferences can be drawn, very intelligible inputs can be drawn when these soil colors are seen with other observable features. There can be a myriad of observable features, texture, whatever you can observe and know, and then you see it with color. Yes, you can have some intelligible inputs to use for management implications. And often not generalized, but soil colors give a clue of other properties. Soil color themselves give a clue of other properties. We'll see in the subsequent slide how this happens. So soil color is actually a soil property that reflects the pedogenic environment and the history. It reflects what the soil has seen through ages. What has been the environment, how hot, how wet, how warm, how cold, how dry earlier years have been, or whatever changes of environment or climate the soils have seen, this all can be reflected in the soil colors. From ages, it can be reflected. But the only requirement is that you need to have a vision of a forensic scientist. I say so, not to mention that, you see, if you would have seen medical detectives on Discovery, you would have come across some incidences where they've used soil information, specifically of the soil color, to solve many criminal cases. So this actually is also being used by the forensic scientists to solve cases. Then the study of soil color is important for soil classification. It's the first step. If you want to classify the soils, the obvious thing is to classify on the basis of how they appear, that is on their color. And then, because these colors also tell you several things about the soil forming processes and the properties of the soils, so they can then be inferred and used further in soil classification. Okay, so next you see, soil colors, they themselves give indications about the soil. And then if we know about the soil, if we know about the soil color, we can draw some interpretations about various properties of the soil. So I'll discuss in terms of some other key points, how these soil colors can give some indications and how we can interpret them in terms of properties of the soil. Having said this, first of all, we'd like to tell you how we can interpret the colors of soil in terms of the contents of various minerals, the moisture content, and the organic matter content of those soils. Anybody with some basic knowledge of soil science would understand that soil color is influenced by its mineral composition as well as the moisture and organic matter contents. When these vary, the colors would vary. Now, specifically coming to some colors, the gray color. If you come across gray color in a soil, it could be due to parent material. Because you see, most of the minerals, after physical weathering, would appear gray. Then with mixing of organic matter and further chemical reactions, oxidation, they would result into some other colors over ages with the soil forming processes. And then gray color also indicates that there has been an incidence of waterlogging. Next, if it's further darker, black color, it could be due to high organic matter content. Obviously, the first thing that comes to mind is a high organic matter content. But if not high organic matter content, this dark color could be due to the presence of dark colored minerals, especially the oxides of manganese. It's possible. And sometimes, you see, embedded in the soil against a different matrix, you can see pigmentation, dark colored pigmentation, which could be due to deposits of the oxides of manganese in a matrix of a different color. Organic matter which darkens soil, but iron oxides, you see, they can produce a range of colors: yellow, red, gray. It depends on the oxidation state of iron in that soil. We'll discuss at what oxidation states, what colors are there. Then soils high in calcium, they tend to be white. Those high in iron are reddish, and those high in humus are dark brown to black. So you see, the content of minerals, water, and organic matter, they also give certain indications, and you can interpret based on your prior knowledge and your requirements for whatever use you want. But you can have certain preliminary inputs about the properties of the soils based on the colors. Next, color also indicates about the ecology and the process of weathering. You see, soil color is a reflection of the age of the soil and the hydrothermal regime. Older soils that have been subjected to intense weathering, okay, they could be red colored, and the soil color is also reflects the hydrothermal regime of the soil. It means what has been the environment, what has been the ecology of that soil, what sort of temperatures the soil has been facing. Could be like warm throughout the year or frozen throughout the year, or could be warm in summers and cold in winters. The range of temperatures could be different, fluctuating temperatures. Similarly, for the water regime, it could be moist throughout the year, wet through the year, waterlogged, dry, or fluctuating, whatever. So this hydrothermal regime could also reflect in differential coloration of the soil. Cooler region soils tend to have grayish or black topsoil, dark colored topsoil. Why? Because there is accumulation of humus. But in moist, warm regions, the soils tend to be more yellowish, brown to red, depending on the hydration. Because in the moist, warm regions, there has been intense weathering. You see, temperature and water, they are the agents which are causing weathering, and as climate, this is called causing weathering. And under these weathered conditions, the oxides of iron, the ferric oxides, if they are hydrated, you'll see yellow coloration, and if they are not hydrated, it will be red. You see in the picture alongside, you'll see the topsoil is red, whereas the subsoil becomes yellow. A classical example where the water table was at a slightly lower depth, so at that point it was yellow. Similarly, the arid soils that tend to be light in color, light staining from low organic content. They are low because the primary production is low. So the organic inputs into the soil are low. And then after decomposition, there's little humus to stain the soil. So largely they are light colored. Then there is also deposition of salts in arid environment, which further adds, when they are light colored salts, this adds to the, uh, sort of white coloration, or sometimes even the salts themselves are visible at the surface, or sometimes in the profile they are visible. Next, the soil color also indicates about the water, the behavior of water, the effects of water. In fact, soil color reflects what is the content of water on a short time scale, because rainwater temporarily darkens the soil color by increasing light absorption. And you see, there are several ramifications for this also. Under waterlogged conditions, iron oxides occur primarily in the ferrous state, reduced, resulting in a subtle bluish gray tint. But if this water table is fluctuating, or the drainage status is only moderate, it's not so good. Sometimes it's waterlogged and sometimes it's aerated. You'll see a mottled appearance, which indicates that this is improperly drained. Then a blackish color, as I said earlier also, if it's not because of organic matter content, it could be because of staining by manganese oxide. They're dark colored minerals. Then soil color also indicates about the thermal regime of the soil, the thermal properties of the soil. Very simply, because color influences the rate of soil warming. You see, if it's dark colored, it will absorb more light. Now, dark soils, irrespective of their moisture content, will absorb more heat than the light colored soils. But then, as a corollary of this, consider that if there is a soil of higher moisture content, obviously its color will be dark. So it will, then again, it will absorb more heat, or more solar radiation, or more light. But because of the presence of water, it will have a high specific heat, so it will warm more slowly than a drier soil. The reverse will also be true. Cooling will also be slower for those soils. And these are some intelligible interpretations which may be kept in mind, because this will give you some information about the soil at its first sight. Okay, now coming to the significance of soil color. You see, what do the soil colors, various soil colors signify? If we are talking of a limited area, say a small farm, okay, or maybe a village, where you see the soils are, by their genesis, they are largely homogeneous. So the color can reliably be associated with important soil properties. In a limited area, color can reliably be associated with some important soil properties. Say, for example, the surface soil color in a limited area, that will tell you about the organic matter content. Very simply, a lighter colored soil should have lower organic matter. It will indicate the soil moisture status. A darker colored soil is wet. Isn't it so? By visually seeing a particular piece of field, you can tell whether it is moist or dry. You see, there are distinct differences. And then if you're not talking of a limited area, then obviously the differences in color could also be because of differences in parent material. So you see, if you want to draw any intelligible inputs from soil color, you have to talk of limited area. Obviously, for larger areas, you can have some inputs, but then you require a greater vision for that. Next, uh, the color of a soil also affects the temperature of the soil. As I said, as I told you in the previous slide, that the color affects the absorption as well as radiation of energy. So it in fact affects the warming as well as cooling of the soils, and hence affects the soil temperature. Soil colors to give some indication of the productivity of the soil. Within a limited area, based on the color of the soils, you can have some interpretations about the relative productivity of the soils. They can also indicate the texture at the first sight. Say, for example, if you see a patch of sand deposited somewhere, you can just visibly see it by noting their color. Obviously, you need to have some previous insights and some perceptions, but with that, you are able to just see that, identify the color, and guess on its texture. Then soil color can also indicate some inherent soil problems such as salinity, because sometimes the salts come on the surface. So if you see that kind of color on the soil surface, you can very well judge the problem of salinity. Although we need to go into further investigations for detailing about these, but a preliminary diagnosis can be done. Next, coming to the causes of specific soil color. Okay, so what are the constituents of the soil which influence the soil colors? The organic matter content, the parent material. First of all, when there is weathering of parent material and there is no transportation of the parent material, it's usual that the color of the soil will be derived from the parent material. The amount of the clay, if it's a mixture of various size soil separate, the amount of clay will also influence the color. The state of iron and manganese in a particular soil, that is the oxidation state of iron and manganese, they will influence the color of the soil. With this background, you see the most commonly recognized soil colors that we encounter are a dark colored soil, dark brown or dark black, to light gray or grayish soils, then red and brown soils, or yellow colored soils, gray or whitish soils. Next, we'll come into the specific reasons for these soils. Okay. So these 5 are the most recognized soil colors. I mean, not on that Munsell chart notation, which we'll be discussing in after a couple of slides, but to a layman, we can say these are the main soil colors. What are those dark soils? See, usually dark colored soils are those that have more organic matter than light colored soils. Humified organic material is dark, but raw organic material might not necessarily be dark. So you see, if it's high on organic matter, but still it's light, it could be because it's having some raw organic material. And for similar organic matter content, the warmer region soils are darker than the colder region soils. And then even if you don't talk about organic matter, you see, you can talk about the black cotton soils in India. Yes. So these soils are because they have formed because of the weathering of volcanic parent material. So they have retained the color of that volcanic parent material. That's why they are black. Irrespective of the content of the organic matter, they are dark colored. So, like I said, that for a limited area, you can have certain interpretations, but for comparing larger areas, is you have to look into other aspects like what is the source of these soils, what parent material, and from where has it come. Next, light gray or grayish soils. They can be indicative of reducing conditions, waterlogged or poor drainage conditions, either at present or sometime in the recent past. These could also be an evidence of reduced iron compounds, reduced to the extent that ferric has been converted to ferric from poor aeration. Because if it's ferric, it could be yellow or red. But when it's ferrous, it converts into light gray or grayish colored soils. Then red and brown soils. Red color is generally due to unhydrated iron oxide. Hematite mineral is there. This color could sometimes also be because of the parent material instead of the soil forming process. The parent material has got hematite, so this does not necessarily reflect that the conditions of weathering are there, because the parent material was hematite, rocks had hematite, and they weathered to form red colored soil. If red soils span over a large geographic region, a well-developed red color indicates old soils with intense weathering, as well as the drainage condition and a good aeration condition. But if it is brown, it could be due to the presence of iron oxides in addition to organic matter. If iron oxides are there and there is also sufficient organic matter, you see, this organic matter could subdue the color of these minerals and the soils would appear black brown. Shades of black and brown. We'll see later how these shades are also designed. Then yellow soils. Yellow or yellowish brown color is due to the oxyhydrides of iron. You see those in the previous slide I told you about the red colored soils, which have got hematite. Now, if this hematite is subjected to some reducing condition, if it has got a hydrated environment, then it can be converted to goethite, where it is converted to the hydrated oxides of iron. And so this red colored soils would transform into yellow colored soils. The dominant minerals in these yellow colored soils are goethite and lepidocrosite. Yellow color in the deeper horizons, if it is in the subsoil, this would indicate a somewhat moist climate than the prevalence of red color. If it's an arid, a largely drier climate, it could be red uniformly throughout the profile. But if it's yellow at a certain depth, it indicates that there is a little bit of more moisture, which has created this environment for conversion of hematite to goethite. And moderate drainage and moderate aeration, this is actually what imparts yellow color. You see, there is rain. If it drains down, obviously the red color would continue through the profile. But if there is a restriction in drainage, drainage is there, but it's not free drainage. So there could be conversion of this red color to yellow color. Then gray or whitish soils. These will appear largely when the dominant minerals are quartz or kaolin, the calcium carbonates, gypsum, and various salt deposits. They will give you this gray or whitish soil. Especially you see this figure which has got the gantic alluvium, which is of this color. And this has got quartz. Then determining soil colors. Coming to identifying the color of the soil on a scientific basis. How do we do that? See, it's natural when we see a particular soil, we can, based on our perception of colors, we can assign a particular color to the soil. But that isn't uniform, that is not uniformly applicable, that isn't uniformly understood. So to have a unique identification of soil color, we need to compare it with a standard color chart. We have a Munsell soil color chart, which is a set of 7 cards in which all the possible soil colors have been listed. And this actually Munsell soil color chart is a subset of Munsell color charts, which have almost 5 times more colors than those found in the soils. And this Munsell color charts is just a subset in which we have included only those charts which are relevant to the colors of the soil. So as you can see in this figure, if this chart book is open, we'll have it in this fashion, colors on one side and their nomenclatures on the left-hand side. The second figure is the classical Munsell soil color charts book, which we have seen in various universities and laboratories. The older one, and nowadays this one, the rightmost figure, this is the latest edition of the Munsell soil color charts book, which is available these days. So determining soil colors using scientific notations with this Munsell soil color chart, we have to understand that the Munsell soil color system, this uses three elements of the color. A color to be classified or to be categorized on a scientific basis has to be identified through its hue, value, and chroma. These three elements have to be identified, and these make up the specific color notations, which are noted in terms of a hue, like here I have written 5Y, followed by a space, and then a numeric 6, which indicates the value, oblique sign, and a numeric, which is chroma. I'll come to what this hue, value, and chroma means in the next slide. But you see, if you can identify color based on three parameters and write it in this fashion, this is unique. And these hue, value, and chroma are again identified based on comparing the actual color of the soil with the colors listed in that book. So what you do is you crush the soil with your hands and compare with the colors available in that book of charts, and just try to find out which is the most, which color in the book of charts resembles the most with the color of your soil. So if you can identify that color, that color in the book has noted the value of hue, value, as well as chroma, and you can have this designation. Now coming to what this hue, value, and chroma means, you see, hue is what? Is simply the dominant color. There are 5 basic colors: blue, green, yellow, red, and purple. Okay, so some combination of these colors is a hue. Okay, for soil, again, it will be limited to, it will not be the whole set for this, but only a subset. But this hue identifies the quality of color registered by the eye. And that is, what is that? Our eyes can perceive certain wavelengths of the electromagnetic spectrum, and with our perception and our prior knowledge for that color, we are able to give a particular name. So this broadly hue actually identifies that very thing, the dominant color of that reflected radiation. Okay, so whether it's blue or red, this is what is hue. And instead of writing in words or in our what we say in our common parlance, the words such as blue, green, we use a notation such as, you see here we've written 10R, 2.5YR, 5YR, 7.5YR, 10YR, 2.5Y, and 5Y. So there are a total of 7 cards representing these 7 hues in the Munsell soil color chart. Each of this indicates the quality of color, and this also indicates the relation of that color to red, yellow, and green, etc. That is, it measures the chromatic composition of light that reaches the eye. But very broadly speaking, hue represents the dominant color of that soil. Okay. But you see, if you identify a particular color yellow, it will again have several shades. Now, how do you classify or characterize those shades? This is done in terms of the value and chroma. Next, coming to value. You see, value just represents whether that shade is light or dark. It indicates the degree of lightness or darkness of a color in relation to a neutral gray color. So you see, if a soil becomes dark, its value will keep on decreasing. So very strictly speaking, value indicates the degree of lightness of a color. And this value extends from pure black, which has got a 0 value, to pure white, which has got a 10 value. As the value increases, we can say that the soil is becoming lighter in color for that particular hue. So value is a measure of the amount of light that reaches the eye under standard lighting conditions. Light or dark, simply. And whatever is the value of light, whatever is the value of that color, that can be indicated by those soil color charts. It's already indicated. You just have to identify the most resembling color of the soil with the various shades given in that chart, and then you can read on the left hand side the value of value or chroma. Next, what is chroma? This is color intensity, relative purity or strength of the spectral color. How bright is that color? So you see, hue is the dominant color. Value gives you the relative lightness or darkness of that color, and this color intensity or brightness is represented by chroma. There could be a color could be dull or it could be very bright. These are the two extremes. So if they are put on a scale of their relative color intensity, we get a thing which is called chroma, and this indicates the degree of dilution of a color by neutral gray or same value. Very simply speaking, if you add white to a color, it will decrease its chroma, and if you add the pigments of that very color, more pigments, or maybe if it's a digital photograph, just consider if you're adding more pixels, it will become a bright color. The scale for this extends from 0 for neutral colors to a chroma of 8 in the soils. Now, having understood what is hue, value, and chroma, we come to nomenclature for soil color. You see, this figure shows how we see these colors in a municipal soil color chart. This is a page for a particular hue, 7.5 YR hue. If you can match a particular soil with any of the color shades here, you can read two things. One is the Munsell notation, which is a combination of the hue, value, and chroma. Hue you can read for a particular chart, it's the same hue. You can read the value on the y-axis and the chroma on the x-axis on these color charts. And then for each particular hue, value, and chroma combination, you can have the color name, which is written on the left-hand side panel of this book. So neither of these alone is adequate for all purposes, but the color names and their limits are given on a diagram opposite to each card, which you can use to describe a particular color. So for describing a particular color, you need to give its Munsell notation and the color name, a standard color name from this book. And before we end, I'd like to tell you something about the cases of non-uniform coloration of soils. You see, soil is a mixture of various minerals, and it's not always a case when you see a very uniform coloration of the soils. At times, there could be non-uniform coloration of soils. some of the cases I have listed. Then how do you describe the soil color in such a case? Okay, so before answering this question, how to nomenclate the color of a in case of non-uniform coloration, let's see what are the conditions when we see non-uniform coloration of the soil. First one, and very common, is mottling, which indicates an improper drainage. So uh, there is some pigmentation with dark red or brown color in a gray colored matrix. Then there could be some pedoturbations in the soil. Suppose there's a soil with distinct color in the color zones in the profile, and subsequently there are some pedoturbations. This could be because of these are some vertical mixing of the soil has occurred. It could be geogenic, it could be because of biological or organisms, or it could be because of human beings, anthropogenic pedoturbations, but they will result in mixing of the soil. And so we won't be able to see the uniform coloration. Then there can be signs of leaching, in which some salts have leached from the surface to the subsoil, or there can be some illuviation or the washing of clays or some minerals from the topsoil to the subsoils, and we can see that in the subsoil, which will break the continuity of that uniform coloration, and we'll see it as a non-uniform coloration of the soil in that region. Then there can be non-uniform composition of that soil. Very simply speaking, strictly a physical mixture of various minerals. So it could be non-uniform coloration. So how do we determine the color in such a case? The ideal yardstick is to, in such a case, is to give the color of the soil as the color of the matrix, the main soil color, and whatever discontinuities are there, they can just be represented as descriptions of these discontinuities of different colors or whatever is there, whatever physical appearance is there, they can be subsequently mentioned after that color. I think that's all for your understanding today, but just a small exercise if you want to test your understanding at your own level, students especially. There are some pertinent questions arising from this lecture. This will be recorded and will be available on YouTube and Facebook page of our university. You can again get back to this and try to answer these questions. I'll just briefly read out these. What do the soil colors signify? What are the three variables of soil color as described in the Munsell notations? What is the significance of soil colors to soil scientists, especially pedologists, agronomists, and engineers? You see, you must understand what these soil colors mean to different sets of people, to different disciplines. Then a dark color soil could be due to, you have to give the reasons and then give your comments. Red and yellow colors of the soil are indicative of what? Why is the soil red or why is the soil yellow? There can be several reasons, but what could be the most pressing reasons or the most likely reasons? Then how do you write the Munsell notations? You must understand. Then you'll be able to write. A soil sample will be darker, lighter. Under dry or wet condition, what sort of combination can you fit in for these two, darker, lighter, and dry, wet? And what will be the reasons for that? If you know how to differentiate between 10YR 5/6 and 5YR 5/6, or you can know which one is brighter, 10YR 5/4 or 10YR 5/6. You see, if you are able to answer these, you'll be able to use the Munsell soil color charts. You can arrange the following colors in the order of decreasing lightness, or maybe like increasing darkness, whatever. What color do you expect in a soil with predominance of quartz, calcareous minerals, gypsum, and the reasons for that? Why is 10yr 6/2 considered a stronger color than 10yr 2/6? These are some of the questions which you should try to work if you want to increase your understanding about soil colors. That's all for today. But before we end, I'd just like to quote the Roman emperor and philosopher Marcus Aurelius, who said that the soul becomes dyed with the color of its thoughts. It means that our inner self reflects what we think. So, taking this analogy to the soils, I would just reiterate that the colors which the soils, the colors in which the soils appear, they actually have a treasure of knowledge, a treasure of knowledge about those soils hidden in them. It's a different thing that our perception and our understanding of those colors in terms of our interpretations for the soil properties based on those colors is limited. But they tell a lot. They tell a lot from what the soils have seen through the ages. And then you see, it's our drawback that our eyes cannot perceive radiation beyond the visible range. Now we have cameras through which we can see beyond the visible range in the ultraviolet and the infrared and beyond microwaves, radio waves. But then you see, this is also now knowledge in the public domain that these wavelength bands, which obviously are an extension of the soil colors, these are being used to decipher soil properties, soil spectroscopy, remote sensing. These are the leading fields which are trying to decipher the knowledge which is conveyed basically by the soil colors. Though in the wavelength bands which are beyond our naked eyes. Thank you very much. And if you have any questions, you can put up on the comments. So I'll get to answer them in a couple of 5 to 10 minutes or. And you can note down my email ID and WhatsApp me also if you need these slides. I'll be happy to share them with you. Thank you. And Shaligramji, if you can just share the questions which they have maybe written on the Facebook or YouTube and give me on my Zoom platform so that I can answer them.